In the last video, we talked about our first examples of combining all of these rules together, in particular the power rule, which I still have on the board behind me. This video is a continuation of that one, so if you haven't watched it, make sure you watch the first one first. And we'll finish up these compilations of all of our rules with a couple of more complicated functions we can take the derivative of. Here's our last couple of examples. Here's our first, slightly more difficult example. I am given the function f of x equals 2 times the fourth root of x, and I want to find the derivative of f. Well, since I just told you about the power rule again, probably I want to adjust this function so that it looks like some coefficient times x to some power. That's exactly what I'm going to do. I remember that the fourth root of x is the same thing as x to the 1/4 power. So the first thing I do is rewrite f of x to look like 2 times x to the 1/4. This is exactly the same function that I had a moment ago. 2 times the fourth root of x is equal to 2 times x to the 1/4. So now this is looking a whole lot like example 3 from the previous video. So I'm going to just use the shortcut and not show you all of the steps. So if you're missing a couple of steps, go back to that other video and watch that one again. So I have f prime of x equal to 2 times, I use the power rule, 1/4 x to the 1/4 minus 1. Simplifying, 2 times 1/4 is 1/2 x to the negative 3/4. So then this 1/2 x to the negative 3/4 is the derivative of the function. Here's our second example of more complicated uses of the power rule. This time I'm given f of x equals 5 divided by x to the 5th minus the third root of x squared. Again, I want to find the derivative of this function, and I want to use the power rule. So first I want to rewrite this function so that it looks like a whole bunch of powers of x with maybe some coefficients on them. Again, that's hopefully not too hard in this case. The first thing I remember is that I just dealt with a fourth root in the previous problem, and the third root works just the same, except I have x squared here, so we'll have to be a little careful how we deal with that one. So I rewrite my function f of x equals, we'll deal with this thing in a second here, but this one is x squared to the 1/3 power. Here, in this case, I remember that x values, or powers of x in the denominator of a fraction can be moved up to the numerator as long as I change the exponent from positive to negative. So I can rewrite this first term as 5x to the negative 5th. Okay, one more little step to rewriting because this doesn't look like a 1 power of x just yet. But I remember my rules of exponents, which say if I have x to some exponent and then the whole thing raised to some other exponent, I multiply those two exponents together. So this is 5x to the negative 5th minus x to the 2 times 1/3 or 2/3. Now this is looking pretty good. None of my exponents are zeros, and so I can use the power rule to figure out what the derivative should be. So I'll again do this by the little bit faster method, so if you want to see it slow down, go back to the first video that we did on this topic. F prime of x is equal to 5 is the coefficient, so nothing happens there. The exponent is negative 5, x to the negative 5 minus 1. And then minus, I use the power rule on x to the 2/3, I get 2/3 x to the 2/3 minus 1. I simplify this expression. 5 times negative 5 is negative 25. And x to the negative 5 minus 1, well, that's negative 6. Be careful with negative exponents. They can surprise you sometimes because it looks like the value is going up when really the value is going down. Finally, we've gotten a lot of practice with this type of thing before. So this is 2/3 x to the negative 1/3. So the derivative of this function, 5 over x to the 5th minus the cube root of x squared, is negative 25x to the negative 6th minus 2/3 x to the negative 1/3. I could certainly rewrite this to look more like the function that I had in the beginning, and that would look like negative 25 over x to the 6th minus 2/3 times, or better be 2/3 over the cube root of x, because this guy is a negative, right? But it doesn't really matter which form you write your answer in, as long as you get the right one. So this concludes our video on more complicated examples using the power rule, the sum rule, and the coefficient rule. But as it turns out, in fact, all we really did in this video was change the examples that we had to look like the examples that we did in the easier video. Make sure you keep that trick in your bag of tricks you can use on calculus problems. Always be trying to change the problem into something that you've seen before. That's always a really great strategy. Good luck with your practice exercises. Make sure if you have a question you post it on the forum, and I will see you later.